This is an example of an indefinite integral problem. They are asking us to find the indefinite integral of this big equation. So 3x squared plus 10x times x cubed plus 5x squared, all of that raised to the third, and then dx at the end. So again, the symbol up in the front, that's saying take the antiderivative of this huge equation here, and the dx is just telling us what variable we care about. So those are really directions telling us what to do to the equation in the middle. As you look at this and say to yourself, how am I going to solve this? As soon as we stop having stuff being added and subtracted, so in this situation, we got things being multiplied, we have equations raised to powers, and so that's definitely not going to fit our power rule, just our basic add one to the power, divide by the new power. It's also not fitting any of our special cases, the ones we just have to have memorized, right? Our trig functions, our inverse trig functions, natural log, any of those ones that you just have to have memorized. And so when it doesn't fit any of those things, the only game left in town really in this class is what's known as U-Substitution. And that's what we're looking at here. So we're looking at a U-Substitution problem. And a U-Substitution problem is a set of side work. We're going to do some work on this equation to take it from something we can't do the antiderivative of and turn it into something we can take the antiderivative of. The beautiful thing about the U-Substitution process is it is the same steps every single time you do it. So once you practice these, it'll be a straightforward process for you. Step one of our U substitution process is going to be to choose our U. When we look at our equation over there, we want to choose a U that we are going to work with. I have sort of my own priority list that I've developed over time. There's nothing hard and fast about this, but it works for me the majority of the time, so this is where I normally go. The first thing that I would go looking for, if it was available, would be the natural log. If I don't see a natural log in the problem, I would choose what I would consider to be the inside piece if I was doing a chain rule problem. So whatever might be inside a set of parentheses, right, raised to a power. The third thing, if that's not there, I would choose the bottom of a fraction. And then generally overall what you're looking for is you generally want to pick the piece with the highest power of x. So working our way through our little checklist here, I would start with the natural log and I would say, well, there's no natural log in this equation over here, and so that can't be my u. I then go to the next one and I say, okay, inside piece. Well, I definitely have an inside piece on this one. That chunk there, that x cubed plus 5x squared, is inside that third power. So this is what I want to choose for my u. It also fits the piece that has the highest power of x. So we start off and we choose our u. So the u for us is going to be x cubed plus 5x squared. From there, step two of the process is always going to be to find the derivative of that piece. So we're going to call this du dx. You always want to use that differential notation, du over dx, as you're doing this. Then we take our derivative, following the power rule. So bring the power down, subtract 1 from the power, move on to the next piece, bring the power down, subtract 1 from the power. From here, the next move is where my special sauce comes in. This is how I like to attack this so that I don't have to see stuff. There's a lot of talk in this section of U-Substitution about you seeing what you need to plug in. And if you just take it this extra little bit here, guess what? We don't have to see anything. It just works for us every single time we do it. When we go to do our substitution, we need everything to talk the language of u. That means we need to change that dx out and have it become a du. To do that, you want to solve this derivative you just found to get dx by itself. So I start by multiplying by dx. We're just doing algebra here to get dx by itself. So I multiply by dx to get it out of the bottom. That's going to get me 3x squared plus 10x and then times dx. And then from there, the next move that I'm going to do is I'm going to go ahead and just divide this over to the other side. So divide by 3x squared plus 10x, divide by 3x squared plus 10x. And so out of there, we now have, those would cancel out, and we get du over 3x squared plus 10x. All of that equals dx. At the end of that part, now what you're going to want to do is you're going to want to do the actual substitution part of this problem. So you start back at your original equation and you work your way left to right through it. And it is either one of the pieces that you are substituting in, or it gets left alone for the time being. So I start off and I still have 3x squared plus 10x. Nothing happened to that. All of that stuff inside my power there, that is now u to the third. And then dx is now going to become du over 3x squared plus 10x. Now, if we've done everything right, what should normally happen right now is we should get some awesome cancellation. Any x's that were left in our problem should cancel out with x's we just plugged in. And sure enough, this chunk here cancels out entirely with that piece there. You rewrite this now. So we have u to the third, du is all that's left over. And this is what I tell people is your reward for all of that hard work, a brand new math problem. What you've ideally done now is taken an antiderivative you didn't know how to handle and turned it into one that you do. And so looking at this, we are psyched because this is just our straight up power rule. Now we come through and we say, okay, I just need to add 1 to the power. So I get u to the fourth, divide by the new power, and then I put plus c. That was just applying the power rule right there. And that's what we're looking for, is at that reward moment, we should be able to take that antiderivative. Then the last move on these U-substitution problems is remind yourself you didn't really care about u, you cared about what u was. And so what you're going to do is you're just going to plug that u back into this equation. And so our u here was the x cubed plus 5x squared. And then like all indefinite integrals, never forget that plus c at the end, right? We don't know what the constant was, but there could have been one there. So we track the fact that it was there by always putting that plus c. So our final result following our U-substitution method looks like that. Thanks for watching my video. If you liked it, please click that like button and subscribe. And also share it with your friends and anyone else you know who might be crying about an upcoming AP Calc test. You can find more videos from me, more sample AP Calc questions, and my complete AP Calc study guide over at my website, apcalcprep.com. Have a great one.